So with this problem here, notice how the denominators are almost the same, but they don't, one of them looks like it needs a little bit of a push to get there. I'm going to take this right side denominator and I'm going to flip it. So I got negative x plus 1, and don't forget there's a 4 above that, and then x over x minus 1, and it's being plus. So x over x minus 1. From here, I'm going to go ahead and factor out a negative 1 to get x minus 1 here. And then I got a 4 on top, and don't forget this is being added. This negative 1 I'm going to apply into this plus sign, so it's going to be x over x minus 1 minus 4 over x minus 1. So the answer should be x minus 4 over x minus 1, because by flipping and factoring out a negative 1, I also found the common denominator. This should be a piece of cake, hopefully. 71. Exponential equation problem. 4 to the 2x plus 5 is equal to 16 to the x plus 1. Alright, 4 to the 2x plus 5 is going to stay exactly where it is. Most people are probably going to try and take the natural log of both sides. You can't do that. Well, you can. You might end up with a bit of a rounding error, though, because natural logs of numbers produce irrational numbers most of the time. So 16, though, can be manipulated to look like a 4, as long as we say that it's 4 squared. And that squared is being raised to the x plus 1. Well, what I have here is 4 to the 2x plus 5 equals 4 to the 2x plus 2. Now that I have the same basis happening, or rather, yeah, the same basis, the exponents have got to be equal, so 2x plus 5 should be equal to 2x plus 2. Those are going to go away, and 5 equals 2. But how often is that true? Never true, so that's why this is no solution. Alright, 50. Okay, here we go. X to the 4th minus y to the 4th over x to the 3rd plus y to the 3rd over x to the 3rd minus y to the 3rd over x plus y. Okay, I'm going to go and parachute this up. This is really times x plus y over x to the 3rd minus y to the 3rd. And now this can go away. Raise your hands if you're okay with that. Everyone okay with what I just did? Okay, I just flipped and multiplied it. Okay, so now I got to go ahead and factor some of these things out. This top part here really is x squared minus y squared times x squared plus y squared. This thing can be refactored, though. So at the end of the day, what I have is x minus y times x plus y times x squared plus y squared. All over this thing here. Anyone remember how to factor that thing? Raise your hands if that parenthesis setup looks familiar. What is this going to become? Little bro, big bro. This is x plus y, x squared minus xy plus y squared, all over, we know this one, well, this is x plus y, that's a piece of cake. This is x minus y times x squared plus, xy plus y squared. So let's start canceling some things. X minus y and x minus y is going to go away. X plus y is going to go away. So what I end up with is x plus y times x squared plus y squared over x squared minus xy plus y squared times x squared plus xy plus y squared. Okay? Those are the 3 problems that we asked, and then we'll reconvene in a little bit. Number 70. Looks like this. You got to find a way to make the bases the same. So hopefully, does it make sense that if I say I have the square root of 125, that's like saying 125 to the 1/2 power. Does that make sense? Those are equivalent statements, yes? Okay. So now I've got to figure out a way to make this 125 look like a 5. So 5 to what power equals 125? 3. But let's not forget, the whole thing was being raised to the 1/2, right? Now, I've got power being raised to a power. What do I do when I have power being raised to a power? This is an Algebra 1 concept. When I have a power being raised to another power, Matthew? Multiply the exponent. So 3 times a half, 3 over 1 times 1 over 2 is 3 over 2. So I have 5 to the x equals 5 to the 3 over 2. I've got the same basis. What does x equal, Kylie? Okay? That's how you do it. Everybody here, we've got an infinite repeating decimal. So what we do here is we identify, everyone, we identify a sub 1. A sub 1 is 0.12. A sub 2 is 0.0012. Anyone know what a sub 3 is? What is a sub 3 in this problem, Ryan? Missing a 0, but that's okay. I know what you meant. Right? Because we want to make sure that if we add all these things together, the numbers will just kind of squash down and we'll get 0.121212. Technically, we only need a sub 1 and a sub 2 because from there we can figure out what r is. So who has a calculator who can calculate r? Ryan. 0.01. We've got a sub 1. We've got r. Do we have enough information to figure out this infinite sum? Yael. A sub 2 divided by a sub 1. Do we have enough information now to calculate the infinite sum? Of course we do. S is equal to 0.12 over 1 minus 0.01. So that is 12.12 over 0.99, which is 12 over 99. They both divide into 3. 4 over 33 is the answer. 181. Six!
What the heck?
Right? No. This is actually 6 times 5 times 4 times 3 times 2 times 1. What is 6 factorial? People have calculators. 30 times 4, that's 120 times 3. That is 360. 720? Look at that. I'm smart. I can do that without a calculator. Okay. Well, we got 2 people in here taking tests. They weren't surprised by 6 factorial. Right? Okay, cool.